Hey everybody, happy Tuesday. Today we are going to be learning about some more exponent rules. And yesterday we talked about the multiplication and the division rule. We're going to add on to that and kind of expand it a little bit. So let's talk about power to a power. Power to a power is basically if we have an exponent with an exponent on it, if you want to think of it that way. So, for example, if we had x to the fourth, and then there's usually parentheses to the sixth, like something like that. This is going to be our distributive property type of rule here. Because what you're going to do is any exponent on the outside, all the stuff on the inside is too, you're going to multiply the exponents together as you go from the outside in. So if we have x to the fourth and then it's all to the sixth, that would be the same thing as saying x to the 24th power. All right, now we could have multiple things with bases inside of here. So for example, if we had 7 x cubed y to the 5th, and that was all to the 4th power, or something like that, then each of these bases in here is going to get this exponent. Be careful with this 7. That's probably one of the most common mistakes that I see people make. Because remember, there's really a 1 on that 7. We talked about that yesterday. So this 4 is going to go to all of these exponents. So it'd be 7 to the 4th power, x to the 12th power, and y to the 20th power. All right? It's always multiply. The parentheses, kind of, that is always what helps me, is I see the parentheses and I think multiply, distribute, right? They go together. Another one that's kind of tricky is fractions. So if I have a fraction, like let's say we had 3 over f to the 4th, and that was all to the 6th power or something like that. The exponent on the outside, when I distribute it, it's going to go to everything on the inside. So that means that it is going to go to the top and to the bottom. So again, remember there's really a 1 here. So we're going to multiply 6 times 1, and we're going to multiply 6 times 4. A lot of times fractions give people tough times because they forget to do both. So that's going to be 3 to the 6th. And make sure, this is another common mistake, don't do 6 times 3 and get 18. It's only exponents. Exponents multiplied by exponents. And then on the bottom here, we would have f to the 24th power. All right, so basically that's power to a power in a very quick and easy to learn way. We take the exponent on the outside, we're going to multiply it by all the exponents on the inside. What else do we want to know about exponents? Well, negative exponents. Negative. So I like to kind of think of this little chart here when we're thinking about negative exponents. Right, so 2 to the 3rd power is 2 times 2 times 2, which is 8. 2 to the 2nd power is 4. 2 to the 1st is 2. I'm interested, I don't know if you guys remember this, what 2 to the 0 power is. But if you put it in your calculator, you'll see that anything to the 0 power is always going to give you 1. Now, why is that true? It's kind of hard to explain. But if you think about our rules that we've learned so far, if you look at like, if we divided 9 to the 4th divided by 9 to the 4th, for example, right? The division rule says that you'd subtract these exponents and you would get 9 to the 0 power. Here, I'm going to write it over here. But we also know that when we have the exact same thing on the top and the bottom of a fraction, that has to equal 1. So if this equals 1 and it equals 9 to the 0 power, then 9 to the 0 power has to equal 1. So there's some really cool mathematical properties on why that's true. It's just going to be hard to remember. So anything in the 0 power, always 1. You just got to remember that. All right. So if we look over here, when we're talking about negative exponents, a lot of times it's confusing and we think it's just going to be a negative number or something like that. But if we look at what's going on here, this is half, half, half. So if we continue the pattern, half of 1 is going to be 1/2. And same thing if I add 2 to the negative second, that'd be half of this, which is 1/4. So what's going on here is when you have a negative exponent, it makes it into a fraction, right? So 2 to the negative first, we flip it. It'd be 1 over 2 to the first power. 2 to the negative second, we flip it. We put 1 over 2 to the second power, which is 4, right? You can see how those are the same. So this negative exponent is just going to basically flip and turn something into a fraction. So, like if I had x to the negative 5th, we're going to put it on the bottom of a fraction. Right now it's on the top. So we turn it into a fraction, 1 over x. And when you change it to the fraction, that is when our exponent's going to turn positive, just like that. Be careful with what actually has the negative exponent on it. So for example, if you had 9a to the negative 4th, well, the 9 is not doing anything, right? It's just to the first power. So there's this rule in math that says you cannot leave anything with a negative exponent. You got to simplify all of those. So if you think about this as always think of it as one big fraction. The 9 doesn't need to move, but the a does, right? I'd have to turn it into a fraction, put it on the bottom. So my answer here is still going to be 9 on the top, and a is going to move to the bottom and be to the positive 4th power. This is usually the one that tricks people up the most. It's just kind of weird, I guess. So let me do some that you will see that maybe would fool you a bit. Let's say you had x to the 9th, y to the negative 6th, z to the negative 4th, right? If I want to simplify this, again, x is fine where it's at, but I need to think of it as a fraction. Y would move because it has a negative, so it's going to flip where it's at. It'd go to the bottom. Z has a negative, it would also flip where it's at. So my final answer, x would stay on the top, y would move to the bottom of the fraction and become positive, and z would move to the bottom of the fraction and become positive. So x to the 9th over y to the 6th, z to the 4th. This makes sense a little bit about why we talked yesterday about the division rule. Some of you in class said, when I told you that when you subtract, you always do top minus bottom, right? That would give you 7 to the negative 6th power. And notice that that would have to then simplify and go 1 over 7 to the 6th. So it makes sense that there's more 7s here on the bottom. Our 7's going to end up on the bottom, right? There would be 6 7s on the bottom. Or the ones where we divided and there was something on the bottom and it's just going to stay on the bottom. That's because it had a negative exponent. It would stay there. Now, I can, in fact, move something. Let me show you this one. Let's say you had 13 f to the negative 6th over g cubed h to the negative 2nd. Right? Actually, we'll make it negative 13, make it fun. If something has a negative exponent, it has to switch the side of the fraction it's on in order to become positive. So negative 13, a lot of people would think, oh, it's negative 13, I got to flip it. But you got to remember what its exponent is. It's only all about the exponent. So negative 13 has a 1 as an exponent. It's fine. It's going to stay on the top. F, however, as a negative, it's got to move to the bottom. G is on the bottom, and it has a positive, so we're going to leave it alone. We don't move it unless it's a negative. H has a negative. It's got to move to the top. So my final answer here when I simplify this is going to be negative 13. H had to move to the top, so it's going to be H to the second. G stayed on the bottom. And F moved down here with G. So you can see where like it's really tricky, you know what I'm saying? Now, what's nice is now that we kind of know all of these rules, man, I'm already at time a little bit here. We can combine them a little bit. So for example, I can say, hey, what about if I want to do 8, a to the 4th, b to the negative 3rd, c to the 6th, all to the 3rd power. Well, I can do power to a power. This 3 is going to go to everything. Remember, there's really a 1 here. Don't forget that. So I'm going to distribute. That would be 8 to the 3rd, a to the 12th, b to the negative 9th, c to the 18th. But I'm not done because there's more I can simplify. I'm not allowed to leave something with a negative exponent. So everything else can't combine, but the b can move to the bottom of this fraction. So I'm going to leave it 8 to the 3rd, a to the 12th, c to the 18th, over b to the 9th power. So now that you kind of know all of these rules, you can combine them and use all of them in the same problem, really, if you wanted to, which is tricky. But the order of those rules, just kind of off the top of my head here, I always do power to a power first, because I think parentheses, that makes me think do, power to a power. Then multiplication and division, it doesn't usually matter. Just whatever one's more convenient. For example, just to kind of show you an example here, I'll do it easy. A to the 4th, b to the 9th, over a to the 10th, b squared, times a cubed, b squared to the 6th, over a, b to the 3rd. All right, this is actually going to have, I think, every rule that we've done. Maybe it will. We'll see. But to show you an example here, I would definitely do power to a power first, because you can't really play nice with everything else if you're still in parentheses. So I'll kind of get rid of those parentheses for me if I power to a power. So that's going to be a to the 18th, b to the 12th. Yeah. And then you can see that I could multiply and go straight across, or I could divide and then multiply. It doesn't really matter. I think it's probably easier to just divide, get the number smaller, and then multiply. That's just me. So 4 minus 10, that's going to be a to the negative 6th. 9 minus 2 is b to the 7th. And then I'm still multiplying here. 18, remember there's only a 1 here. That would be a to the 17th. And 12 minus 3 is going to be b to the 9th. And now you can multiply and go across and add. That's going to be a to the 11th and b to the 16th. Now, the very last thing I would do is check to see if any of them are negative. Then I would fix those. So if either of those turned out to be negative there, then I would rewrite them in fraction form. Okay? a lot of stuff. I know for a 15-minute video, that was a lot. But if you guys have any questions, definitely, make sure you come to office hours tomorrow. You can hit me up on email or in Remind, and I will help you guys out. Hopefully this is reviewing and you remember it, so it won't be too bad. All right, I'll see you guys later.